So we're doing the exact same thing where we talked about how we need to multiply our binomials or whatever together, but we are going to do it in a function now. So instead of just having this, we have y equals instead. That's the only difference. Somebody tell me what standard form is from page 50. Our goal is to get it in this form. This is standard form. It's x squared, xc. Notice how it's actually labeled standard form in order. There's no parentheses. That's what standard form really is. All right, from that page, I think factored form is on there too. This is the factored form that your book gives, but here's something I do not like. Do you see this A and this A? They're not the same at all. This B and this B, they're not the same at all. That's why I don't love it, but that's what your book uses. I think that is what the real factored form is. Maybe it needs to be called something else one day, but it's not my favorite there, but we'll get over it today. Later this week and next week, we're going to learn how to actually factor these, but for now, we are going to multiply them out. We're going to multiply these together first, and there is a reason, you'll see why in a minute. And then we're going to distribute the 2 to everything. So, let's do that first. And you already know how. How do we multiply 2 of these binomials, 2 sets together? Distribute. X times x is x squared. You're probably sick and tired of doing this by now. X times negative 4. Somebody said it, I just didn't hear it. Negative 4x. 1 times x. 1x, okay, and 1 times negative 4. Do I have like terms? Okay, how do I put them together? Add these two, so it's x squared. Then what? And then minus 4. Alright, notice that 2 is still out there. We got to bring that down. I now need to distribute the 2 to everything. Make sure it gets distributed to every single piece. What is 2 times x squared? 2 times negative 3x. And 2 times negative 4. That is the answer. That is standard form. Here's my factor form. Here's my standard form. I want you guys to do numbers 2 and 3. The only difference in what we did the other day, there's a y in front and you have to distribute a number. You don't even have to distribute a number on number 3. Alright guys, number 2. What did you get when you multiplied these two binomials together? X squared minus 2x minus 5x plus 10. Okay, then what? Yeah, you combine the negative 2x and the negative 5x, and you get negative 7x. Okay, then what? Plus 10. Now what? You multiply everything by 3. Plus 30, did you say? There is standard form. Number 3 is nice because I'm not going to have to actually do an extra step. What did you guys get when you multiplied the binomials? Minus 7x, and then what? Okay, and combining got you what? Plus 7. Alright, number 4 looks different. Sadly, it's like 3 problems in 1 problem. You do have some of those. We're going to have enough time to work on your assignment because we literally have this one left. it gives you x-intercepts. So before we even talk about that, A and B are x-intercepts. There are a lot of different names for those x-intercepts. They might be called x-intercepts. They might be called zeros. We'll see that this week. They might be called roots. They might be called solutions. You need to know that it could be all of those words. They're x-intercepts, they're zeros, they're roots, they're solutions. For now, though, they are called x-intercepts. So here's what we're going to do. We're going to start this without the k value. We're going to look at just this. We're going to add the k value back in just a minute, but it will save us some time to not do the k value first. So we literally take 2 and 5 and plug them in for A and B. The formula is already negative. So our answers here, not answers, plugging in, they're going to stay negative because the formula is negative. What if our x-intercepts were negative? It would become a positive. We need to work this out, and I want you guys to go ahead and work it out. What is x minus 2 times x minus 5? Plus what? Did we not already do that? We did almost. Number 2. So y equals x squared minus 7x plus 10. Alright, now we're going to draw a line. This is not actually the problem. This is what we're going to use in a minute. What we are actually doing, we're going to set up and equate this for when k equals 1, when k equals negative 2, and when k equals 3. K is actually right in front. I already found out what this combined is. It's right here. So for each of these, when k equals 1, I'm going to put a 1 outside and what I found out in parentheses. I'm just replacing it right there. Now what happens when I multiply everything by 1? It stays the same. So when k equals 1, nothing's going to change. Y is going to equal x squared minus 7x plus 10. But how about when k equals negative 2? Will something change? Yes. We're going to set this one up too as y equals negative 2. We're going to plug in the same thing we did up here. X squared minus 7x plus 10. I want you to distribute that negative 2. You finished distributing the negative 2? when you distribute a -2, you have y equals what? -2x squared. Then what? Plus 14x minus 20. You need to do that again when k equals 3. It's frozen. You can't see. All right. Do it again when k equals 3. How are you going to set that up for k equals 3? What are you going to write down? 3, then what? Okay, go ahead and do that one too. Hey, I've got my surf at your own risk. I'm just going to put that down. Alright, you distributed and got y equals 3x squared minus 20x plus 30. 21x. I said 20x. We're going to talk tomorrow, more about what these x-intercepts actually mean. We talked about x-intercepts before. Do you remember what x-intercept is? Where is it on a graph? Where it crosses the x-axis. Yep. It's been a little bit since we've done it. We had to come back and do this because we didn't know how to multiply binomials yet. Alright, glue that on 51. You should already have the title. It is representing quadratic functions. I'll put that up there though if you need it. So 51 representing quadratic functions. Homework's in your book. I say homework. You have enough time. Nobody should have a problem finishing it today. Page 958. 5 through 14. 5 through 14? Yes. And 17 and 18. So work on that. You've got the whole time.